Hello. Hello. Hi. Welcome to today's tutorial session. So it's 7. I think we'll wait for around 5 more minutes or 3 to 5 minutes. Let's see how many joins and then we'll begin.
Yes, ma'am. Good evening, ma'am. Sure, ma'am. We'll wait.
Yeah. Okay. Hello. Hi, good evening, everybody. Am I audible and my video visible?
Yes, ma'am.
Okay, great. So, yeah, so I think people are just joining in. Let them join in. So, meanwhile, we'll just slowly get into the session. So, I see that it's a very small crowd right now. So, this session is mainly meant to be more of an interactive session where we'll discuss some problems, we'll discuss about the assignment questions, not the ones which you submitted recently or just about to submit, but similar kind of questions we'll discuss a few questions. And if you have any doubts regarding this week's assignment or the weekly lectures, we can discuss all that. So it's going to be an interactive session. So I think again, since it's a small crowd, I think it's feasible for us to start by just introducing ourselves because I would also get to have a better idea on the group that I'm interacting with. So, can we have some volunteers who can introduce themselves and yeah, I think can I ask Parthasarathi to kindly introduce yourself because you were the first one here.
Ma'am, sorry to say, but yesterday only I joined the course, ma'am.
Right.
Still, I didn't watch any videos. So I
Okay.
just joined the session to know how it goes. So for that I joined.
Yeah. That's totally
Yeah,
fine.
that's totally fine.
I can understand
I can
that.
understand that.
I'm sorry. Can you mute for
Sorry,
a
can you
minute?
mute for
Because
a
I'm
minute?
hearing a
Okay,
lot of
sorry, ma'am.
echo.
Sorry, ma'am. Sorry,
Yeah,
sorry
you
for
can
that.
unmute after that. Yeah, sorry. Because I could hear myself. So, yeah. So, yeah, that's totally fine. So, since the course just started last week, I'm sure that many of you might not have seen the videos also. So, it's fine. So, we'll see how we can attempt the assignments. And in that, we'll again have an overview of whatever was there in the course during the week. But I suggest from the next week onwards, at least a day, in one day, if you see at least one lecture, then that would be good because you'll have that continuity when you're doing your assignments. Because seeing everything in one go, things might not get into the head. So, yeah, so right now, today's session, don't worry, even if you have not seen the assignment, it's okay. We'll start from the basics and we'll go very slowly. So, yeah, so could you kindly unmute yourself again and then say what are you currently doing and yeah, exactly. What are you currently doing or
Doing or Ma'am, I've joined my master's in Anna University, environmental engineering as my major.
right.
Right. So
So,
I think it will be useful for that course also. This one for my
okay.
future too.
Yes, yes,
Okay.
yes, it
Yeah.
will be useful. And I'm assuming that you're from Tamil Nadu.
Yes, ma'am.
Okay, great. Yeah, so it's nice to have you here. Uh, can somebody else volunteer to introduce themselves? Maybe Manoj or hello? Okay, or Jivanshu. Yeah, you can proceed. I'm sorry.
Yeah,
Good
good
evening,
evening,
madam.
ma'am. Ma'am, I'm Jivanshu from Gwalior, Madhya Pradesh, and I'm currently doing my bachelor's in planning.
Bachelor's in planning. Where are you doing it from?
Yes, ma'am. Ma'am, NIT Bhopal.
NIT Bhopal. Oh, great. That's good.
Yes, ma'am.
Okay, good to have you here. Yes, Manoj, could you kindly introduce yourself?
Good evening, madam. I am Manoj Avalgaonkar. I have just retired from Water Resource Department of Government of Maharashtra.
Okay,
Uh, yes, I'm basically BE Civil. I have done ME Environment, but mostly worked in Water Resource Department.
okay, that's good. So
Thank
yes,
you.
I think your inputs would also be very valuable over here because you have a lot of experience in work experience in this regard. So I
Yes,
think
yes. My domain is Water Resource Department. Yes, I
okay,
want to explore in water supply and drainage.
that's nice. That's interesting. So yes, it's really good to have you here. I mean, I think we can also, like all of us, can also learn a lot from you. So yes, the interactive session is going to be really insightful.
Yes,
Uh,
thank you.
yeah, thank you. And yes, so can we have the next participant? I see, I'm just going by the list that I have here. So I see Gopi Sainath.
Hi, very good evening.
Yes.
Yeah, my name is Gopi Sanath. I'm an assistant professor from Beva University.
Okay,
I joined this course for my students
that's
to
great.
resolve their doubts and all those things.
That's great. Yes, so I think
Yeah.
we can also learn a lot from you also in this
Mm,
course.
yeah.
Okay, great. Can we have the next? So I see a Sivraj Singh.
Good evening, ma'am. Myself, Shivraj Singh Shekhawat from Ajmer, Rajasthan. Uh, I am employed in a school as a office superintendent, and for this course, it will help for our drainage and so on problems. Recently, Rajasthan has the heaviest rainfall in all over India. I see in IMD reports also.
Mm-hmm. Yes. That's great. That's great. So yes, I hope the course will be useful. We will, as the course progresses, we will learn some practical scenarios also on how to manage drainage, how to rainwater harvesting. So a lot of things. Yeah, we will be discussing those in detail. So yes, it's going to be very much beneficial in practically looking into these aspects also. Great. Uh, so
Thank
uh,
you.
Next, I think we just have two more participants. Yeah. Galif, if I'm pronouncing it right. Galif?
Yeah, hello everyone.
Yes,
Hello.
yes, Galif.
Yeah, this is Galif. Yeah, I work with a government department which look after the water supply, electric supply, and all type of resources of the defense. So I just joined this group to improve my knowledge in this area.
Okay, that's great. Yes. So that it's wonderful to have you here. And next, can we have Ishwar? Ishwar, are you there? Okay, it's great to have such a very diverse crowd over here. Many of you have a lot of experience. Many of you are already into academics. Some of you want to implement this. I feel the interactive sessions are going to be really insightful. So just to introduce myself, I am Jeslu. I am currently a research scholar in at IIT Kharagpur. I'm working with Professor Devapratam Pandit, who deals with this course. I'm a Prime Minister's research fellow, so I'm currently in my fifth year. So I've been doing my research in IIT Kharagpur for 5 years. I'm planning to complete this year. So this online PMRF live sessions, sorry, or NPTEL live sessions are mostly conducted by PMRF scholars as part of a teaching deliverable which is being given by the Ministry of Education. So this is part of a deliverable that we are doing. I see that many of you are much more experienced than me. I feel that maybe you can call me Jeslu. That's also fine because I mean, or else I would also have to address a lot of you by sir, sirs. Whichever is comfortable with you. So I think we have a good crowd now. So with that, we can enter onto our live session. So I'm just sharing my presentation. Yes. Uh-oh. I'm really sorry. I think my internet got a bit weak. Am I audible and is my screen visible right now? No, I think I'm not audible. Hello. Uh, am I audible? Can some of you confirm? No. Jitin, my internet കിട്ടുന്നില്ല. Okay, I am so sorry that some internet issue happened right when we were about to begin. So I'm really sorry about that. I think I'm audible right now, right? Can some of you confirm?
Yes, ma'am.
Okay, yeah.
Yes,
That's
yes.
that's good. That's good. So I'm just sharing my presentation. So I'll just join in my. Um, okay, it's loading. It's just 1 minute. It was fine before. Yep. Yes. So, yes. So I hope my screen's visible. Full screen? Can some of you confirm?
Yes, ma'am.
Okay, great.
Ma'am,
Yeah.
just
Yeah.
a con-
So yes, Jivanshu?
ma'am, like, do we have to like first see the lectures to understand like what you're doing?
Okay, yeah. So, the idea of the live sessions is that you've already seen the lectures, all
Not yet.
5 lectures, and you've already attempted your assignment, and you're facing some difficulties while doing the assignment. So this is the premise which we are thinking, but it's totally fine if you have not attempted the assignment also, because we will discuss few questions from previous year's assignment so that you will be able to solve your assignments better, or if you're facing some difficulties, you'll be able to solve that better. So yeah, watching the videos might be a good idea because this is just a 2 hour session, so we may not be able to cover all the topics in detail as much as how the professor explains in the video. So in this, we will. I might usually talk with the assumption that you already know it, but in case you are facing some difficulties or you're not understanding anything, you can always pause and you can always ask. I can always explain it to you. It's not an issue. So if you've not seen the video also, you can still be in this live sessions. It's fine, but yeah, better it's to watch again. So yes, so again, a very good evening, everybody, and welcome to the first live session of Urban Utilities and Planning, Water Supply, Sanitation and Drainage by Professor Devapratam Pandit. So as we were interacting, I'm Jeslu, and I will be handling all the live sessions every Monday from 7 p.m. to 9 p.m. So these are the topics which we discussed in this week's lecture. So in the first lecture, we discussed about certain urban utilities planning issues. We went into the details of sanitation issues, water supply issues, drainage issues, waste management issues. So all those we delved into details, and we even saw some case studies on how these have been affecting badly in the Indian context. We saw the floods in Chennai, the floods in Kerala. We discussed about how the drainage pipes and the sanitation networks have been not laid properly, and because of that, a lot of congestion and decline in water qualities. All these we discussed in detail. And now, considering this in lecture 2, we saw, or in the lecture 2 videos, Professor discusses in very much detail about the different planning strategies on how do we design, how do we plan, how do we implement, and how do we do the operation and maintenance considering these. So what is the planning period or the design period that we design? What is the carrying capacity? So all these details we discussed over there. We even saw on how do we plan for the people, how do we project the population or predict what will be the population a few years later, so that we can plan our facilities or services for the people for a certain period of time. So all those population projection methods also we discussed. And then in lecture 3, again we continued with different planning strategies, and we saw how different government policies and different strategies have been implemented. Then in lecture 4, we again saw different urban utilities and how they are being done. And in the last lecture, we saw mainly about water sensitive urban planning, on how a water city develops into a sustainable city, and then or a only drainage city, and then finally moves on to a water sensitive city, or a fully sustainable conservative city. So all these we've seen in details. So yes, so let's get into the questions and we'll try solving these questions. So before we begin, I just have some simple ground rules which we will be following every week. My slide's not changing. One sec. Yeah, side changed. Okay, so first thing is we'll go problem by problem, every problem, and after we discuss every problem, we'll have an interactive session where we can, if you have any doubts, you can discuss. And towards the end of today's session, again we'll have a 5 to 10 minute window where you can discuss doubts regarding these questions which we're discussing, and also any other doubts which you faced during this week. So we're focusing on only this week currently. So next week again we'll go into only next week content. So if you have anything, it's better of this week's, it's better to discuss now itself. And yeah, so again, internet is very it's kind of flexible. So if at all my video is stuck, I might not be able to know. So feel free to interrupt, or if you have any doubt, also feel free to interrupt. So I would suggest, since we have a few numericals in today's session, so it would be good if you have a pen, paper, and if you can solve it with me, so that any calculation related issues also be solved in the process. So yes, so let's get started. So we'll start with a very simple question. So which among the following causes decline in groundwater level? So we are starting with this question. So we have first option as uncontrolled and illegal extraction, second one as rapid urbanization and construction of concrete surfaces, lack of enough water recharge structures. So to give a premise, what is groundwater decline? Can somebody come up with their observation on what do we mean by groundwater decline? Okay, so we have uh, we have a groundwater level which is usually recharged through rainfall or any surface water source. So it percolates underneath and it recharges the groundwater. So if this is the ground, we have a groundwater level. But when we have certain, and we also extract groundwater for our potable purposes and other purposes. Sorry, let me just add someone in. No, okay, everybody's added. Yeah, sorry. Yeah, so we keep extracting also. So now whenever the extraction, so if this is A, which is the recharge which is happening, and if this is B, if any at any point if B is greater than A, then our groundwater levels will reduce. And if A is greater than B, then groundwater level can increase. So there's always a fluctuation which is there. So here the question asks is what causes the decline in groundwater level? So just to give you a premise, so in India, the groundwater level has depleted about 10 to 25 millimeters per year. So every year from 2002 to 2016, there is a 25 millimeter decline which is happening. So you can see the rate which is there. And 54% of India's groundwater wells are declining. So this is a serious issue which is happening. So we need to identify what are the reasons why this decline is happening so that we can find measures how this can be sorted. So we have got 5 options for this. So let's look at every option one by one. So first one is uncontrolled and illegal extraction. So what happens in uncontrolled and illegal extraction is that, so as the same thing as we are discussing, so when there is illegal extraction, that means there's no accounting. So we do not know how much of water is being extracted, so which means certain companies or certain people are extracting more than what others are extracting. So this again leads to bias in extraction, and also it because of excessive extraction, it leads to a decline in groundwater level. And illegal, again, the problem is because it's illegal, they're not paying a lot for it. So when the cost is less, again you extract more because you're not paying for it. So there are two aspects which is happening over there. There's a lot of wastage because of cost, and also because of bulk extraction. There's a lot of bulk extraction. So again, here in this case, what happens is if we have some recharge A which is happening, and if we have we have an extraction B, in this case, B is always greater than A in most of the cases which we have seen. So, uncontrolled and illegal extraction is one of the reason for groundwater decline. And the second option that we have is rapid urbanization. So, will urbanization lead to increase in water level or decrease in water level? Any observation?
It will increase, ma'am.
It will lead to
Decrease.
increase in
No, no,
water level.
decrease. No, decrease in water level.
Decrease
Decrease
in
in groundwater level.
Decrease, ma'am.
decrease in groundwater levels too. Okay, so let's see what's happening in this case. So we have a groundwater, and like we have a groundwater source, and through some through rainfall and from through the surfaces, some water is percolating and going. So as we were discussing, this is A. So this A is fixed. We're assuming that A is fixed. So initially, it is serving around a population of, let's say, like around 100 people are there in that particular locality. So around 100 packs it's serving. Now, at the next period, so this is in time period one. At the next period, because of rapid urbanization, if this increases to around 200 packs, they would need more water. So they would keep extracting more water. So which means, but A is always fixed. So whatever is coming into or whatever is recharging is always fixed. But the extraction or the quantity which is required right now because of increased in urbanization is more. So because of this, there'll always be a decline in groundwater level, and that is some that this is what is mainly happened in most of the Indian cities, and this rapid urbanization has led to decline in groundwater. So we need to find, so as a solution, we need to find, because of urbanization, we need to increase the source A. If we can increase the source A, then again, we can balance it out. But is it possible to increase A? That's another question which we'll have to deal, which we'll have to we will discuss those in the later lectures. So, but when we assume that A is fixed and if there's increased or rapid urbanization, then there's always a decline in groundwater level. That's one thing. Now let's go to the next. So this is again, yes, A. This is B is also right. Now the option C is construction of concrete surfaces. So what happens? Any observations?
It obstructs the percolation rate of.
Exactly, it objects a percolation rate. Correct. So the same example, same thing that we're discussing. So what happens when it obstructs the percolation rate? A reduces. So if A reduces, then obviously the amount of recharge which is coming in is reducing. So this again, and if the amount which is going out, B is fixed. If A is reducing and B is constant, this again reduces the groundwater level. So this is again in most of the cities. This is a major problem, and because of this, rather than making complete concrete surfaces, we you might have observed in most of the pavements we create paver blocks with grass or open space where water can percolate inside. This also reduces compared to a complete open floor. This is again a reduction, but compared to a complete concrete surface, this helps in some amount of percolation onto the groundwater level. So and also because sorry, I went to the next question. Yeah, because of these paved surfaces, the surface runoff increases. By surface runoff means all the water which is there on the surface without percolating, it goes directly into the surface water bodies such as rivers or lakes, and it goes into those water bodies, and the groundwater level reduces because of this. Okay, so the last one is lack of enough water recharge structures. What happens in this case? It's the same thing, like it's the same as option C, that if it reduces the if concrete surfaces reduces the percolation level, and water recharge structures are used in order to increase the percolation level. So in the lecture we've discussed about certain recharge structures, swamps or dams, which are usually created where water the surface runoff come these are certain depressions on the ground where surface runoff comes and gets stored. Now because of the semi permeable nature of the soil, this is stored over here, and it goes and recharges the groundwater. Whereas it would, if it was a complete flat surface, water might just fall and immediately go into the nearby water body. So these are water recharge structures which are on purpose constructed in order to increase the groundwater recharge. So if we do not have lack of enough groundwater recharge structure, again obviously the percolation rate is reducing, and because of that there's a decline in groundwater level. So to answer this question, all the four options A, B, C, and D reduce. So which is there in our option D, that is D. A, B, C, and D reduces groundwater level. So that was the first question. Now, any doubts on this question? I don't think so. Yes, I think I went very slow on this question also. So that's okay. Let's go to the next question, which is somebody has raised their hand. Yeah, Galif.
Yeah. Regarding the first option,
Mhm.
is there any law which prevents people from extracting water, groundwater?
Uh,
because
yeah,
it
that's
is
an
an
interesting. That's an
uncontrolled extraction.
Yes, an illegal extraction is mainly spoken about. So, about a law, again, I'm not very sure whether there's a law regarding that, but this option again mainly talks about illegal extraction, which means that it's not accounted anywhere. So, usually, whenever there is groundwater pumping, or we are taking some groundwater, you have, or if it's a if you have a permit, you have a residential permit, so there's an accounting on the groundwater sources which are there, and yeah, there's some accounting which is there, but here mainly we're talking about, or if there's a company, then whatever they're doing, it has to be recorded. But this mainly we are talking about illegal extraction, which means there's no accounting, and this is the problem in India, because we don't have much data. So as you know, even in residences, if we take more water, there is no method as of now to find out how much water is being taken by a particular person. So that's again illegal. Like, it's illegal in the sense, mainly we are talking about there's no accounting of the water resource that we are consuming. If there's some supply which is coming, like there's a through our pipelines we're getting some supply, there is some amount of accounting which is there for that. But whatever where there's no accounting, we're talking about uncontrolled and illegal extraction over here. Regarding a law, again, I'll check that and I'll let you know. So to my knowledge, it's not there, but I'll have to check more on that.
No, yes, ma'am. There are laws. In at
Okay.
least in Maharashtra, there is law,
Okay, that's
and
great.
yes,
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 so could
yes.
you enlighten more about that? Because that's good. Yes. Are
No,
there?
I just know. I definitely can say there is law, but the detailed provisions I am not knowing. And again,
Hmm.
even if there is law, it's very difficult to implement it because
Exactly. Exactly.
that
Yes.
is the
So,
case.
yes, I was mainly talking about the implementation part, where if you have a well and there is no accounting for it, you don't know how much is being extracted. So that
Yes.
part, I think India is still lacking a bit. So we need to do something about that. Yes. So any other doubts? Okay. So let's proceed further to the next question. So yes, so this one is a population projection question. So a population of a district based on census data is given. So we have for 1991, 2001, and 2011. And we've been asked to forecast the population for 2031 based on arithmetic increase method. So we have learned about different population forecast methods, mathematical methods, and economic based methods. So here we are following the mathematical method and the most simple mathematical method, which is the arithmetic increase method. So let's get started in this. So I think we can work on this together. So I'm just rewriting the data again so that we have clarity while we are doing it. So for year population and so for year and population, I'm writing. So first one we have 1991, we have around 80500. Then in 2001, that's increasing to 535000. Then in 2011, that's increased to 1036000. So let's look at what is the increase which happened every year. So from 1991 to 2001, for this period, the increase would be 53500 minus 80500. What's that?
454,500.
Yes, correct. 454500. Now, from for these 2 years, what is the increase?
501,000.
Correct. So now, so we have basically for one first decade, this is the increase. Second decade, this is the increase. So mainly we are talking about a 20-year increase period. So 20 years, this much is increased. So if we want to find the total increase which is there in one decade, it would be, sorry, what is the total increase which is there? We can sum this up, and that is
1036,000.
1036.
I think so.
This is 5, sorry, this is 5. Am I wrong somewhere? Is it 955 double 955,500 that you're getting? 555, yeah, correct. 955,500.
Yes, ma'am.
So now, if you want to find the in one decade, like average in one decade, how much it's increasing? Because we have 2 decades, 20 years. So average in one decade would be this one divided by 2. 9,555,000 divided by 2, which is, am I right, or did my
Yes,
calculation
ma'am.
go? Okay, correct.
Yes, ma'am.
Yes. So to find arithmetic in, so for arithmetic increase, the formula that we're using is, so for a period t, that is for a for a projected period where we want to find the population projection t, is equal to base population plus the year that we are, so this t minus the base year, and all this we're doing it in decades, because in the question again the value that we have it is in decades. So year minus the base year in decades into m, which is the arithmetic mean. So this is what we found right now, the arithmetic mean, which was m was 477,750. This is what we found in the previous one. So let's see. So in this case, so we know m. Now we know the base population also. Now what is this one? The year and year minus year in decades. So here we have the data from 1991, and we've been asked to find for 2031. So that's like 1991 and 2031. So we have like 40. So which means for 4 decades, we've been asked to find the population projection after 4 decades. So let's put all of that in this formula. So we have the base population, which is 80. So let's see, PT is equal to 80500 plus the year, which is 4 into, so this is fully under the bracket, into, now M we found, which is here. So that was 477,750. So what does that come up to? Yes, so what's the final answer?
1991500.
Correct, 1991500. So is that there in our options? This was the, no, this was not the question. Yeah, so let's, yeah, so this was the question. So that's there as option B. Yes, so 1991500. Great. So any doubts in this question?
Like, couldn't we have taken just the population of 2011, then added?
Yeah, we could do that also. So we can, so then the number of decades would vary. We can do that way, but again, the value might vary a bit, but approximately you will get a similar value. But here we are following that we are taking the base population, and then we are taking the progression, whatever was there, and then we are calculating. So both methods are right. One sec, somebody wants to join the call. Okay, great. So let's proceed on to the next question. Question 3. For given population data, what is the forecasted population for 2031 based on the incremental increase method? So we discussed, okay, so is there anybody in this group who watched all the videos? Okay, nobody. At least this
Yeah,
part. Okay, you saw all the videos. Yeah.
yeah,
So
yeah.
great. So I think two of you have raised your hands. I'm very new to this hand raising in Google Meet, so maybe I might not see that. So you can unmute and say that's better, because I'm going full screen to present. So this hand raise, it's not being visible for me much. So yeah, great. So yeah, so let's. What were the three mathematical methods which we discussed in the lecture? Can somebody quickly summarize those? Three mathematical methods for population forecasting. Any of you?
Geometric,
Yeah. So
arithmetic, incremental.
yes, great. So we have arithmetic increase method, geometric increase method, and the this one incremental increase method. So arithmetic, we have already done one problem on that. It's a very basic. We are assuming that the population growth is uniform based on the increase that's there every year. So we are taking the average population growth. And in geometric increase method, we take the geometric increase or the progression. We take the ratio and then find out what is the uh, geometric mean for each of the years, and then based on that we do the projection. And incremental increase method, we consider both the factors. So that is, sorry, we consider there's an increase which is happening, and then for every year there is an incremental increase also which is happening. Like for instance, in the previous year compared to the first 2 years, the third and the second and third year, the change which was there was different. So in incremental increase method, we will consider that also. We'll do this problem and then it would be very clear. So again, we are starting off with by rewriting the whole thing because it's easier to do that way. So year, and we have the population. So in 1971, we have around 60,000. 1981, we have 65,000. 1991, we have 82,000. And in 2001, we have 10500. 2011, we have 13200. Okay, so let's first find the increase. So this is similar to what we did before. So from this year, from the first year to the second year, what's the increase? So yeah, so what's it?
5,000.
Yeah, so this is very simple, 5,000. Next 2 years,
17,000.
correct. Next 2 years,
23,000.
very good. Next 2 years,
27,000.
27,000. Great. So what's the overall increase? We sum it up. The overall, to find the overall increase, we sum it up. So that is,
72.
yeah, 72,000. Great. So, so this much we know. We already did this in, sorry. So, somebody's trying to join. No. Okay, great. Yeah, so this much we've already done. Now, the formula for incremental increase method is that for a time period t, like the population projection for a time period t is equal to P0, where P0 is the initial population, which we saw in the previous one, plus t into mi. So this much is same for arithmetical increase method. So this is the rate of increase each year, or basically the arithmetic mean which we have, and t is again the time in decades which we saw before. Now the additional, in incremental increase, the addition which comes here is plus, we have a t into t plus 1 divided by 2 into k. So this k is the rate of change or rate of change in increase every year, and we're taking the mean of that. So from first year to second year, from second year, the difference, the increase for every year, how much is the increase varying? So for that, what we do, so this is our increase. So we have, this is the first, second, third, fourth increase which we have. So from this year to, from first to second increase, how much is changed? So 17,000 minus
5,000.
5,000. Yeah, correct. Sorry. Yeah. So that is 12,000 here. Then the next one,
6,000.
6,000. The next one,
4,000.
4,000. Now here one important factor that we must consider is the sign. So here, since all the increased values are greater than the previous one, it's all positive. But there can be instances when the increase is less. For instance, if this was just 7,000, then we're having a lesser increase in the uh, in 2011, or in the later years it's a lesser increase. So in that case we'll have to take a negative sign over here, because we want to find the total increase which is there in all these decades. So we'll have to sum up the positives and negatives together. So yes, so what is the total incremental increase? Sum this up, that is
22.
correct. Yeah, 22,000. 20, yeah, 2,200. Sorry, 20.
10
Well,
plus.
sorry, I missed a zero. Yeah, 22. Yeah, correct. So yes, so now we are going back to the formula. So here, in order to find, so time in decades, this one we know it's 4 because we already did that. So you have 1, 2, 3, and 4. So our t is equal to 4, which is fixed. Yeah. So in order to find the total increase, the total increase which we got was 72,000. Now what will be the average increase? or M value will be 72,000 divided by 4, which is
18,000.
18,000. Now we need to find K also. So for K, what is the value that we have? So we have only 1, 2, and 3. Three incremental increases are there in the overall. So to find the average incremental increase, it would be 22,000 divided by 3, which is
7,333.
yeah, 7,333. So it would keep going that way. So I'm sorry, I mentioned TS4 over here. That's not this T because this is a projection T what we want. This is just the value which is given in the data. That's not the T that we are putting it over here. By mistake, I said that. So we need to find this T now. Like what is the how many years are we projecting it for? So that's there in the question. We need to project it for 2031. So as we discussed here, we are again going with the base population method. Like we are calculating the base population and we are calculating the projection. So from 1971 to 2031, what is the number of decades that we have to project it for?
6.
6, correct. So we are projecting it for 6 decades. So let's plug in, so T is equal to 6. Let's plug in everything in the formula. So first one, it is base population is 60,000 plus we have our T, which is 6 into MI, which is 18,000, plus we have T again 6 into 6 plus 1 divided by 2 into our 7333.3. Okay. Yeah, so what does this work out to? 6 into 1,800 plus 6 into 7 divided by 2, that is 21. Yes, so what does this work out to? Okay, I'm just
3
writing. Yeah, correct. Tell me, what's the answer?
3,21,000 something. 3,21,999.
Yeah, something. So approximately we can say that it is 3,22,000. Like it's 3,21,099. 321,999.93, like it'll just go. So why I'm saying approximately because
So
in
someone has a
the
different answer.
someone has a different answer. Sorry.
Someone has 3,17,000 799.3.
Okay, so let's see. Let me not jump into the answer then. So as is are you getting this much right? Like 16800 plus 15399. Like I think this is where you might be going
3 lakh
wrong.
20, 3 lakh 22,000 I am getting.
Correct. Yeah. So yeah. So because if you add this both, yeah, this is what you would be getting. So approximately it'll be 3,22,000. And in case you use the other, like if you start using the population of 2011, you might get a bit more different answer. But eventually, when you round it off everything, it should come up to around 3,22,000. So let's go back to the option. It's not there. Yeah. So why we're doing is again note round off to the closest integer. They said yeah, it definitely closest integer. So I think the answer is option C, 3,22,000. Right. So any doubts in this question? No doubt. Yes. So let's proceed further. So we have done arithmetic increase method and incremental increase method. Geometric increase method, one problem we will do towards the end, like this session. So we'll deal with some theory questions before that. So yes, so let's go into that. Which of the following statements are correct concerning the design period of water supply, sewerage, and drainage infrastructure? So this question mainly talks about the design period. So what do we mean by the design period?
The period of time till the scheme would sustain.
Very good. Yes. So it's it's mainly the time for which we are planning a facility. So you're planning a water supply facility, we are designing it for a certain period. So it should, like for instance, if you're designing it for 30 years, for the next 30
Rolling.
years, this facility should be able to serve the people where it's been planned for. So yes, you're right. It's the period for which we are planning the facility. So here in terms of here we are mainly talking about water supply, water utilities or urban utilities is what we are talking about. So the period for which the utility would sustain or the infrastructure is designed for this particular period. So usually we take a design period of about 30 years is the usual design period which is taken. And if the construction, like for instance, I'm planning to build a utility, and if the construction of the utility takes about 5 years to construct, then after completing the facility, after the facility is built, from that period onwards, for the next 30 years, the facility should sustain. So design period is calculated from the time when the facility is built or is commissioned. But for every component, for instance, if you have a water supply facility, the water storage structure may have a design period of say 30 years, but but a pump which is used for that may have a design period of only 15 years, because
15
it, yes, exactly, so it can vary. So for every component, the design period can vary. So this should be mentioned in the operation maintenance, and this is designed for this design period, so it needs to be upgraded after. So when we're doing the budgeting, everything, all this comes into play. So that's the overview of design period. So in this particular question, they mainly asked about two aspects, about population growth and land use. So will this affect the design period? So before we look into this question, let's also look into what are the different factors which influence design period. So this is directly from the lecture. So we saw that the life of each component affects the design period. That is what we were discussing right now, that if something sustains for a very short time, then the design period of that would be less. So that would also influence the overall design period also. Then expansion opportunity. So will expansion opportunity increase or decrease design period?
Decrease.
Will decrease the design period. Yes, could you say why you feel so?
Because the demand will lower on will get lower and shrunk up. The demand will get shrunk up. That is why. So expansion in terms of population will actually indirectly proportional to the demand.
Yeah, correct. You're absolutely right. So yes, you're talking mainly about population, but in general, if there's an expansion opportunity, like you're building some facility, and if you feel that in the future that facility can be improved due to other infrastructural facilities which are going to come up, or some institutional facilities, or some policies which are going to come up. So for whatever reason, if you see that there's an expansion opportunity, then designing that for a very long time is futile, because when the expansion opportunity comes, this is not going to be used. So or the exactly what you said, the demand would shrink, or the facility is going to be redundant at that point of time. So designing it for a very long period of time is not worth, the investment that we're putting in is not worth. So if we see an expansion opportunity, then the design period should automatically be reduced, considering the time when this expansion would be there. Now what about available finances? Will that increase or decrease the design period? Now that's a bit tricky. So, yes, what are your observations on that? If you have more finance, will it? Yes, somebody.
Will decrease design period.
If you have more finance, then the design period will reduce.
No, no. It will with more finance. We can have more design period.
Yes, we can have more design period. Yes, good. So mainly, yes, somebody has a difference of opinion. Yes, Gaurav.
No, ma'am. No, ma'am.
Yeah, okay. So yeah, so it's both ways. Like for instance, if you have a lot of initial finance available, like if you can invest in your capital a lot, then yes, you can plan it for a longer duration, because investing for a or designing for or planning a facility for a longer design period involves a lot of capital investment. So if you don't have the adequate facility finances, yes, the design period will reduce. But again, it should be linked with other factors. That is, if there's an expansion opportunity, or if you're going to get more finance at a later stage, then yes, quality and durability, yes, that it also influences that. So yes, if you're going to get more finance at a later stage, then we can plan it in stages, or design something for a short period and then plan for an improvement at a later stage. So finance obviously influences the development that we can have. Now, rate of interest, obviously the same thing. If it is at a higher rate of interest that we're getting it, then we cannot invest more. So we'll have a restriction over there. Then availability of land for future expansion. So that's again expansion opportunity. So finally, we come on to our population growth and land use. So for population growth and land, yeah. So let's go into population growth. I think like we already discussed this. So if the just to explain it more, like for instance, if the so we have a certain facility or a certain utility system, and it's catering to a group of people, say A, and the initial population was around, like the same example we'll take was around 100 packs, and then it's slowly increasing to 200, 300. So over the years, so if I built it in 2001, by 2010, uh, it's steadily increasing, and let's say I've designed it for 600 people. So by the time it's 2010, like I'm assuming, like the rate of growth, it's a very slow growth which is there. So by 2010, it is reaching its maximum. Let's say this is A, which is the maximum. So it's reaching the maximum, which means it took 10 years for the population to reach that maximum for which the facility was designed for. So this is the design period. Now imagine the growth is exponential, and within the first 3 years itself, the population is reaching this A, or 600 packs. Which means if you design it for 10 years, then the facility is not capable enough to serve the population growth in that particular area, which means it is becoming redundant, and we might have to build another facility. So with increase in population growth or rapid urbanization, uh, the design period, if you
Ye-
see, if you can sorry, yes.
Yes, ma'am. If population and land use growth is increasing, then design period is, I think, decrease.
Very good. Yes, design period should decrease. That's the observation. Yes, design. So so we saw how if population is increasing, how design period should reduce. Now, what about land use growth? Could you say why you feel that if land use growth is also increasing, then design period should reduce?
Because, ma'am, if we use rapidly land use, then so many changes can affect design period.
So many changes can affect design period. Okay, yeah, you're right, you're absolutely right. It influences, and it influences, that we're sure. Whether it's a positive or negative influence, let's just look a bit more detail. So similar to this population growth, what happens is that if you have a facility, so you're designing a facility considering, so this is facility say B that you're designing for, and you know that this is the land use over here, this is, so this facility is going to uh, serve these areas. Now, with variation in land use, or when land use is growing, imagine the land use in this particular region over here, which which suddenly started to grow. So, which means there's a lot of demand from that side, and the demand in this has reduced. So, which means the facilities should now be able to cater this area more than this area. So now your transportation cost or conveyance cost of the utility to this area is again increasing. So when there's a change in land use, or there's a sudden growth in land use in certain regions, so this, you see that this is a spatial change which is there. So with such small spatial changes also, our facility is becoming redundant. That is, it is able to cater to all these the requirement which is there, but the facility or the conveyance cost or the carrying cost increases. So again, because of this, the immediate tendency would be to have another facility in the center of this in this particular area or somewhere nearby, so that the conveyance cost reduces. So same reason, like with population and land use growth, there's a both spatial, and so this we are talking about a temporal change which is there. That is the design, we are reducing the design period because temporarily the, or with time, the rate of growth is lesser in the first case, or the with time the rate of growth is more. If the rate of growth is more, then we'll have to go for a smaller design period. But similarly, if you see that spatially also in the region also, if you see a non-uniform growth or a heterogeneous growth happening in certain regions, then again you will have to consider your design period and reduce it, so that more facilities can come up in regions where it's growing, because sometimes we'll not be able to predict where the growth is going to be in. We can predict it for a certain small duration, so for that small duration we'll have to plan. So yes, so both population and land use growth influences design period. So let's see in this first one, growth rate of population affects design period. Yes, that is true, it affects. Now, growth rate of population does not affect design period. No, it affects design period. Now, slow change in land use increases design period. Does it?
No,
Slow change of land use increases design period? No.
Yes,
no,
ma'am.
Yes.
no. Faster change increases the design period.
Faster change in land use
Sorry.
increases the
Yes,
design
yes,
period.
yes, yes.
Yes, so
No,
I
no.
think
Faster change decrease the design period.
correct. Faster change in land use. So design period again, it's a duration. It's a duration that we're talking about. So as the design period increases, that means it's going to stay for a longer time and it'll need more capital investment. And if the land use is changing, then investing so much for a changing place is not going to be useful. So yes, so the option D is correct. Faster change in land use increases the design period. Slow change in land use increases design period is false. So the answer would be B, A, and C. Right. So, any doubts in this question? Shall we proceed further?
Mom, uh,
Yes.
like you said D was right, then like in the options you select the B.
Oh, sorry. A and D. Sorry, I marked it wrong, right? Faster change. Oh, sorry. Faster change in land use increases design period. No, slow change.
Yeah.
Sorry. I marked it wrong. I also read it wrong. Sorry. Slow change in land use increases design period. A and C is correct. D is wrong. Faster change in land use decreases design period.
Yes,
Slowly,
answer.
I read it wrong. Nice. Good, you pointed it out. A and C is a right answer. Yeah. Yeah. So, let's proceed further. Question 5. Which of the following statements are correct concerning mathematical models for population forecast? So this is we already did two problems on mathematical models. So let's look into some, like, because some of you said that you're not able to go through the lecture. So I'll go into the theory part first. So mathematical models, there are two mathematical models. Again, it's used for population prediction, and what it does is it takes the history, or in a place how the population has grown over the years, that data is collected in order to estimate the population growth for a future time period. So if you have like for a, so I'm just putting it as h, so based on historical data you're predicting the future. So this is one method that mathematical models does. Then there's a second way, is that if you have the data of a region which is very similar to this particular region, so we look at the growth rate happening in that region. For instance, you have region A, which is growing at a steady rate, and you have region B, and looking at the historic data, you know that B is also growing at a steady rate. So if you have the population data of A for a particular time period and how the great growth has happened, we can predict that B will also grow in the same rate. So from a similar region, how the growth rate has progressed, we take that data in order to predict what will be the future of that particular region. So yes. So these are two methods. So that's what we're discussing. So we take the growth rate from a past period or from an other population growth which is similar characteristics. Now the one of the constraint in this is that we are only looking at the data. We are only looking at the total number of people who is number that is increased. We are not looking into any societal or economic changes which has happened over time, which means we're not giving any reasoning onto why this increase or decrease happened. We're just saying that from 2000 to 2020, 2010, X amount of increase was there. 2010 to 20, this much increase was there. So overall, this is the increase. So it's a pure mathematical method that we are following. So because of this, we are not considering age groups or gender, or we are not separating. But what happens is that in an actual diverse region, population does not the rate of growth for every age group, for every gender, will not be the same. Even the death rate or the birth rate for different age groups would be different. So we need to consider all those. So this is the reason why we have certain economic, sorry, I went to a different question. Yeah, different economic models also. So now in mathematical models, we have the arithmetic increase method, incremental increase we already saw. We also have the geometric increase method. There are other methods also called the logistic curve method and graphical method. So here we have, let's go back to the question. We have been asked about mathematical uh, models. So yes, so the first question is that mathematical models are suitable when population growth is regular. Is that right?
Yes.
Yes, so that's right. So that's what we are saying, that there's a pattern in population growth. So we learned, so those three methods we'll see. So, which we saw that we have the arithmetic increase method, which mainly gives a steady rate based on, so if this is the, with time t, what is the growth which is happening? It's always a steady rate that we are talking about. It can be this way or it can be this way, like a slow, steady rate. So basically, it's a steady, which means it's a straight line. It's a steady rate, so it's only for a regular. So imagine an industry is coming up in a region, which means there'll be a sudden change, and in the industry is coming after 10 years. Like from the data that we're taking from 2000 to 2010, there is no industry is growing. Suddenly 2010, one industry has come up. So which means from 2010 to 2020, the population growth will be very different from how it was before. So there's an irregular growth which has happened because of certain societal factors which has come into action in that region. So, and for such regions, mathematical models are not suitable. So it's only suitable for places where it's regular. So this was arithmetic increase method. Now, if it is geometric increase method, which means there's an exponential growth which is happening. So which means the graph would be something like this. So if it's geometric increase, which means within a short time, exponentially the region is growing. So this is suitable. The same example if you're taking the industry. So the industry has come up this year. Now for the next 5 years, it is going to grow exponentially because of this industry. So for that short period of time, we can say that it's a very fastly growing population. There'll be rapid urbanization because of certain societal factors. But again, we're not considered about the societal factors, but we know that it is going to increase. So that is going to be a geometric increase method. Now the incremental increase method lies somewhere between this both arithmetic increase and geometric increase method, because that considers the arithmetic increase as well as the rate of change in the increase every year. So it will lie somewhere in between. I would suggest to watch the video lecture on this, because sir has very beautifully explained this in the video lecture. And also there is one more course on transportation. So in that NPTEL course, in that also Professor Devapradam Pandit has very beautifully explained how these methods, how these different mathematical models are used, economic models are used, and in which context it has to be used. So yes, so this is, yes, it's used when the population growth is regular. Now the next one, mathematical models consider that no major societal and economic changes have occurred. Is this right?
Yes, ma'am.
Yes.
Yes, it considers. So that is the whole assumption in which mathematical models are based on. Now, say, third option, mathematical models consider different population age groups and gender. Is that right?
No, ma'am.
No.
No. So which model considers different population age groups and gender? Okay, it's some economic models. So we will see those economic models right now. Then the last option, so this is wrong. It does not. Mathematical models predict population using population growth rate from the past period.
Yes,
Is that
ma'am.
right?
Yes, ma'am.
Yeah, so that's what we discussed. So A, B, and D are right in this case. So C is incorrect. So the question is asked for what is the incorrect option. So yeah, so what we need to mark is C. Yeah, so this is one thing which I guess you'll have to get used to in the assignment, because sometimes there would be questions like what is incorrect, what is false, which of the following statements are not true. So usually that's where people go wrong also. So I think that part, even in your exam, such a bit, sometimes we might not read the question properly. So I think that part you can keep in mind. So yeah, so here C is the correct answer because that's the wrong option which is there. So yes, yeah. So we have certain population. These are some economic models. So we have so this is what I was trying to explain to you before, to say that if there's an arithmetic increase method, it's a slow rate. Geometric increase method, it's a very fast rate of increase. And if it is an incremental increase method, it's a steady, which lies between geometric and arithmetic. Now different economic methods, these are mainly used when there's an economic events which play a major role in the population growth. So we learned in our lectures, we learned about four methods: employment method, ratio method, migration and natural increase method, and cohort survival method. In this, the last two, migration and natural increase method and cohort survival method, are mainly used. Cohort survival method is the best method. So employment method, it just looks at total number of people who are, the ratio of number of people who are employed every year. And ratio method also takes the ratio of people. Now the find the migration and natural increase. Yeah, so migration and natural increase method, what it does, it looks into the in migration and out migration, how many people are coming and going, and it looks into the live births, how many people are being uh, natural increase, yeah, the birth rate and the death rate also. But one problem is that it considers the birth rate and death rate for the entire population to be the same, whereas for based on different age groups, for instance, the death rate of a very old person, like for about 90 plus years old person, would be much higher than a healthy adult. So the migration or natural increase method does not consider different age groups. That is done in the cohort survival method. So in cohort survival method, we first divide based on age groups. Now for every age group, a birth rate is given, and then we calculate the projection, and based on death rate, we subtract the number of people who would not be there in that population group. So it's a tedious calculation procedure. In the video lecture, one small example also has been shown. So that's mostly used for accurate prediction. But again, since we're dealing with urban utilities, we're dealing for a bulk population, so we need not know the exact number of people who would be there. Like we can have a estimate idea, that's okay. But when we're dealing for any other facility planning, such as transportation facilities, or some other more detail, like or real estate development, so for all those things we might need more accurate data. So then we'll have to go for these economic models also. So yes, so this was a question that we were discussing. So we said that C is the uh, answer that we need to mark for this. Yes, so any doubts in this? Shall we proceed further? Yeah, I'm proceeding further. Which of the following statements is false concerning public-private partnership in utility provision projects? So what is a public-private partnership model? Yeah, okay. Yes, you can answer. Hello?
Combination of government and private entity.
Correct. Combination of government and private entities. So basically, government delegates certain duties to private entities to carry out certain services. So in our lecture three, we saw into detail on how public-private partnerships came into being. Also, how it was initially initially what was we looked into the examples of American European cities, how it happened. We saw the emergence of private partnership. So mainly the idea is that it delegates responsibility to, so in case of our urban utilities, we're saying that for urban water and sanitation services, so there's a contract which is made, and based on the contract, a private operator gives these services. Now, there can be also management contracts where the private operator takes care of most of only the management responsibility. So different types of contracts are there, which are there. So all this comes under the public-private partnership. So now the issues related to this, or what are the factors or concerns that we need to always look into while a public private partnership is drawn, is that there is always a risk of this one private in yeah increases there's an always risk which is involved, which leads to cost escalation, and also we need to have some check on the cost escalation which is there. So we need to have and why this is happening, because sometimes which we do when we don't have much data, or when much facilities are not provided, then there's a lot of problems which are there. So for brownfield projects where which already there's some existing services something there, and lack of data, so if this is not provided by the government, then it can lead to a cost escalation later. Then we also, if the so the fund which comes to public private partnership is a public fund. So if we don't have, if there's no adequate public fund, or if there's poor capital investment, again the efficiency reduces. Now if the contract is weak, and if by weak contract you mean that the private partner do not see much incentive in providing services, then again there's a risk of the service quality being reduced. Now, yes, now also the arrangement between the local body, urban local body, and the contractor is also weak. Then also there's a problem. Then there's a staff transition issues, like if some other company is taking over, what happens to the staff? Then communication between stakeholder arrangement, then tariff. So when the government sets the tariff, or if the public private partner is setting the tariff, then how do you negotiate? Where do you draw the line? So there are a lot of issues which are there. So based on all this, a contract is always drawn. So all these factors are usually mentioned in the contract, and the public private partnership is established by considering all this. So here the question what we have is that which of the following statements are false concerning public private partnerships? So some concerns, that's the question over here. So first option A says that efficiency in capital investment is poor as a result of public fund availability. Is that true?
Yes, ma'am.
uh, Efficiency in capital investment is poor. Yeah, so it like in the
Rate of
sense,
return is very low.
yeah, exactly. So if you don't have capital investment, then yeah, efficiency is cap because it's public fund. That's what we discussed. Because it's public fund, efficiency is low, which means again there's very limited that the private partner can do if there's no capital. So this is correct. This is correct. Now,
Ma'am, we have point
PPP
12.
performance is affected by low incentive. Is that right?
Yes, ma'am.
Yes.
Yes, we discussed. If there's no, if it's low incentive, then private partners do not see any advantage of doing. So that's also correct. Now, PPP efficiency is affected by government policies. Is that right?
Yes, ma'am.
Yes.
Yes, because it's again, government is delegating the duty. Now, the last one, PPP efficiency is independent of contract targets.
False.
False, yeah.
False.
So this is here we need to mark what is false. So D will be the correct answer. It's not independent of contract targets. Everything is put under the contract. Right. So we are proceeding further. Question 7. Which of the following is false concerning bioremediation of water? So first, okay, let's go into the options. Use of living organisms to remove organic matter in a water body involves on-site treatment to degrade pollutants to less toxic forms, involves desiltation of water bodies, involves a mechanical process to remove organic content in soil. So let's see what is bioremediation. What is bioremediation?
To removing biological waste, organic waste, biological waste
Yes,
from
so
water.
correct. So I mean, from the term itself, we can say there's bio, so you have biological waste in the water. So it's a water treatment that we're doing in order to remove the impurities from water. So all the bio, to remove all the bio impurities, we're using a bioremediation. So it's mainly a bioremedy. So it's mainly used for sewage treatment, where microbes are used in order to like degrade a flowing water, flowing sewage into carbon dioxide and water. So this is what is done. So it's a sewage treatment process which is there. So the process, how it happens is that you simply input or introduce certain microbes into this water, and they will eat up all the contaminants such as oil, organic matter, and everything. So once they eat them up, now they are converting them into, so they eat, now the biological process is happening, and because of that
It is
they,
a, ma'am, pardon, it is a technique of STP
yeah,
MBBR.
yeah, it's a technique of sewage treatment, correct. I mention water purification? Sorry, I think I made a mistake there. Yeah, it's a sewage treatment process.
MBBR.
Yeah.
Okay.
By mistake, we have included oil, madam. Oil should not be included. Oil is
Is
not a
it?
biological one.
Is it? Okay. So, okay. So which means it's okay. This, okay. I'll have to check this. The book, okay, the book which I was referring to, it was there, but I'll definitely get back to you regarding this. So you're saying that it doesn't eat up oil; it only eats up the organic matter, right? Right. Okay. Fine. So yeah, so mainly this is used to check contaminants and all. And the whole advantage is that it does not require any mechanical method, because it's a total biological process that's happening. So we don't need any mechanical equipment or major modifications in the drains. Correct. So let's go back to the options. So first one, use of living organisms to remove organic matter in a water body. Correct. Second one, it involves on-site treatment to degrade pollutants to less toxic forms. Is that right?
Correct.
Correct. Yes, because it just releases it out to carbon dioxide, all the organic matter. Now, C, it involves desiltation of water bodies. Yes, that's also
No.
right. No, yes, that's also right. So it basically removes all the silt and organic components which are there, right? So it involves desiltation of water bodies. So that also it is used. Now, the last option is that it involves a mechanical process to remove organic content in a soil, which is
Wrong.
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 Yeah, it does not involve any mechanical process. It's a totally natural biological process that's being used. So correct.
Madam,
So it,
you have to again check desiltation also, because siltation means it is inorganic.
okay, but
We will have to check it.
yeah. So I think
Siltation
this
means
part.
inorganic.
Yes,
Silt means
siltation.
inorganic.
Yeah, siltation means inorganic. Okay, so yeah, I'll check this both oil and this one, but I'm sure that it removes, like it can be used for desiltation also. So that part is also there. So I'll get back during the next week. So maybe it's not just used for organic. So yeah.
Okay.
So yeah, so the option for this one is involves a mechanical process to remove. So option D is the correct answer in this case. So yes, so now let's go on to a geometrical increase method progression problem. So predict the population for a year 2000, so multiple years, 2021, 2031, 2041 from the following population data. So let's get started with this the same way we'll do. So I'm just writing it here. Yeah, so for 1961, we have a population. I'll just write it here in a new page. 8545. This is the population. 1971, it's 1015672. 1981, it's 1201553. 1991, it's 1691538, and in 2001 it's 2077820, and in 2011 the population is 2585862. So this is the data which is given to us now. Okay, so first obviously we find the increase. So what's the increase that's there? So the arithmetic increase from year 1 to, so we'll just do the subtraction. That is
157127.
7127. Then this one it's
18.
correct. Please check. I may also go wrong. So
Last one is like 507742, if I'm not wrong.
507. No, this one is 25856. Could you check that once more?
Yeah, sorry. My
Hmm.
bad.
Okay. So everybody with me till here? Can I proceed? Okay, I'm proceeding. So now, sorry. Yeah. So now we have the geometrical increase. So geometrical increase is mainly the ratio. So for 1 year, what is the increase divided by the base population? So so we have one, two, three, four, five time periods. So for the first year, what is the from first time period to second time period? Uh, Sorry, yeah, for first time period, for every time period we're doing it. For first time period, what is the increase? So that is 157127 divided by 858545. What's that? Around 0.18.
Yes, ma'am.
Yeah. So let's do it for all the years then. So yes, so for the second year, how much is it? 0.16. Uh, okay. Anybody else, any different answer?
0.18.
0.18. Yeah, even I'm getting 0.18. Then next year, what's the answer? Anybody? Either in the chat box or you can speak it out. What's the answer for the next year? Sorry. Where did we go? 0.4, yes, correct. 0.4 is correct. Then for the next year, the fourth year or the fourth time period. Anybody? 2.27 or 0.227? It's 0.227, so I'm putting it as 0.23. And for the final one, 0.24, correct. 0.24. Yes, 0.244. Yes, let's take 0.24. So these are also, yeah, so one, two, three, four. Yeah. So now we need to, yeah, so again, let's just go back. So what's our overall formula to find the, this one? It's projection at time period. So let's take the formula. So projection at time period PT is equal to P0, which is the base population, into 1 plus M raised to T, where M is the geometric increase or the geometric mean, and T is the time period. This is, so how do we find the geometric mean from all these all these? So what's the normal, the general formula to find the geometric mean is that you take the summation, sorry, not summation, I'm sorry. You take the you multiply all the aspects. So you multiply all the geometric mean, like all the geometric differences or the ratio, sorry, ratios that you found. Sorry, I went to a different slide. Yeah, so you multiply them for I equal to 1 to n, and then you take the nth root of that. So this is the general formula in order to find the geometric mean. So in this case, we'll have our geometric mean as 0.18 into 0.18 into zero point 0.4 into 0.23 into 0.24. Now the whole raised to 1 by how many time periods did we have? We have 5. 1, 2, 3, 4, 5. So raised to 1 by 5, or the fifth root of the product of these. So that works out to Yes, I'm waiting for your answers. Yes, anybody? Point 244. Uh, okay. Approximately right. Anybody else? Oh, that was for the previous one. I think I just got it delivered now. Is there anybody else getting any other answer? Is it 0.244 that everybody is getting? Yeah, 0.234. Yes. Uh, 0.234. Yes, that's what even I got. So I got 0.234. So yes, so that's the geometric mean. So now we have the geometric mean. So for this, we only need the geometric mean basically. So just to rewrite the formula, Pt is equal to P0 into 1 plus m the whole raised to t. So now for P 2021, so we have the data. Yeah, so for in this case, uh, we have two options as we discussed for all the case before case also. We can take the base population and then look at the exponential growth, and we can increase the t accordingly, or we can do the other way where we can take the population data. So here we have population data given till 2011, so we can even take 2011's data and then see for how many more years are we or how many more decades are we calculating it for. So since we did the other, we took the base population for the previous cases. Here let's do it this way just to see that both methods are right. So we can take 2011's data, which is going back, it's 258586. So 2585862 into, now if it's 2011, then 2021 is just 10 years, so which means t is equal to, so in this case t is equal to 1. So into 1 plus m is 0.234 raised to 1. What does that work out to? Is everybody getting this answer? I guess that's a simple calculation. Everybody? Yeah, 9. Oh yeah, yeah, right, right. Yeah, it'll be what, yes. So I actually took it as 2.35, so that's why I'm getting a slightly different answer. But yeah, the answers which was there, I think I'll go by that one, like 3190953. Yeah, that's the answer if you're taking 1.234. Correct. So this is the answer. So now one more reason why we're taking this one, base population as 2011 data, is that this is exponential growth. So which means for every year it's exponentially growing. So more chances of getting a more accurate answer or a more realistic representation of how much it's growing is when we take the the data that we have, the present data. So because if we take the previous data, again, we have taken the average arithmetic increase, right? Sorry, average geomet or the geometric mean is what we have taken. So the errors which are there for every year, so the error from 2000, from which was the data, yeah, from 1961 to 1971 there'll be a small error. 1971 to 81 there'll be another small error. So when it comes to the exponential method or geometrical increase method, these errors can exponentially increase and it may even lead to a wrong answer. So for geometric progression method, it's always better to take the base population as the data which is already given to us. So that's one thing. Now let's see for 2031, same way. So 2585862 into 1 plus 0.02324 raised to, so 2031, so raised to 2. So what does that work out to? Nine three nine 37636. Correct, correct, correct. Yeah, so 3937636.8. Yes, and now 2041 it would be. So 2041 it would be 3. So that is, yeah, 4856. Yeah, 4859044. Correct. So that will be 4859044. Yes, anybody getting any different answer? No, so approximately, so based on the value, so some decimal places we might have rounded off in the initial case itself. So in that case, we might get a slightly different answer, but the idea is overall this should be the answer. So I think let's go back to the options. Okay, there's no option in this. Yeah, we just needed to enter the final answer. So yeah, so we have the final answer for all the 3 years that we've been asked for. So that's about geometrical increase method. So we are proceeding on further. Any doubts in this? No. Let's go further. So, which among the following, which among the given themes of Composite Water Management Index, CWMI, accounts for the maximum weight? Source augmentation and restoration of water bodies, watershed development, supply side management, participatory irrigation practices, or domain. Oh, sorry, this is a wrong option which just came in here. Like that's a typing mistake. I'm so sorry. Watershed development, participatory irrigation practices, policy and governance. So this is what we saw in the lecture in about composite water management index. So there are certain indicators or certain themes that are followed, and every theme is given certain weightages based on the priority that we need to look into, or based on the immediate attention that is needed. So in that, so there are nine themes that we have, and 28, sorry, and 28 indicators. So here we are mainly talking about the 9 themes. So our first theme is source augmentation and restoration of water bodies. So by source we can have the source. So you can have a groundwater source, you can have a surface water source. So we need to we need to restore the water bodies, or uh, main problem is contamination of water bodies, or depletion of groundwater levels, or surface water drying up. So all those we need to tackle these problems, and we need to strengthen the source from which we are getting water. So those comes into these first 2 themes. And for groundwater augmentation alone, we have 15 as the weightage, 15%. So if the total were total for 100, so we have 15% weightage only for groundwater augmentation, and 5 for augmentation and restoration of other water bodies. Now then we have major and medium irrigation. So that would be, oh yeah, so it's a supply side management, yes, and watershed development, which is again the supply side management. Then we have the participatory irrigation practices, which is the demand side management. Now why yes, so because irrigation we are taking, so that's a demand side management. So what do we manage in the demand side? Then we have sustainable on-farm practices, rural drinking water to make the. So yeah, so in rural areas, contamination of water becomes a major issue, and the poor quality of drinking water has led to several diseases, which I think we will see in our upcoming lectures on the how water contamination has affected the lives of people. So under our composite water management, this is given a lot of importance, around 10%. Then urban water supply and sanitation about 10%, and policy and governance around 15%, because eventually it's all based on the policies that we can manage the whole thing. So coming back to this one, Yeah, so watershed development is the supply side management, and irrigation practices based on that demand side management also. So coming on to the options we have, which of these account for the maximum weightage? So we just saw that policy and governance has around 15% weightage, so that accounts for the maximum weightage. So this is a very pure theory question which is there from the standard, so nothing much to explain on that. So I'm proceeding on further. Sustainable Development Goal 6 adopted by United Nations envisages availability and dash of water for all by 2030. Any guesses?
Usage.
Yeah. Okay. Anybody else?
Someone is saying A.
A, sustainable management. Yeah. Okay. Anybody else? Anything? Okay, so let's rule out the options. So distribution, yes, it's a very basic thing. So that's not included as a sustainable development goal by so availability and it's not distribution. Equitable distribution again. Equitable distribution. Okay, sustainable development goal 6. It's been very particular about that. That does not talk about equitable distribution also. Sustainable usage to an extent we can say yes, but we always have a better option which is sustainable management. Sustainable development, if this management was not there, maybe sustainable usage could have been one, because it mainly talks about making it available to the people and managing it properly. So that's the development goal. So the answer is sustainable management. This is again, it's directly based on the words which has been formulated in sustainable development goal 6. So yeah, so such kind of not tricky, like very trivial but word centric questions can also be there in the assignments and in your question paper. So I think certain aspects we might have to remember. That's all I can say. So this was there in the previous question paper, so I included it in the discussion right now. So this one, question 11, yeah. So we will look at different public-private partnership models with the method of function. So when we discussed about PPP models, we discussed about different contractual agreements that can be there and different methods by which the roles are delegated. So let's see what each name stands for. So first one is yeah. So A, divestitures. What is that? Or what is the explanation for that? Method of functioning for that? Any guesses? Okay, let's go by the ones which we. Oh yeah, somebody's put. What is this for C? Infra C is what in? Oh, you're saying C option is correct.
Yes, ma'am. I only know the that B concession is in first the fourth one.
Concessions are for what? Concessions are for
Publicly owned utilities managed by private operator.
concessions are for publicly owned utilities managed by private operator. Okay. Okay.
Basically, we call it a concessionaire agreement. Mostly the operation maintenance part of the any project or any infrastructure project, especially with the water supply and drainage, we call it a concessionaire project. That is why I only know that this B is somehow related to 4.
Okay. Okay. Fine. So maybe I mean you're partially right, but eventually everything all are delegation. Like it's all a most of these are again publicly owned utility, which is we are delegating it to somebody else. So let's see, is there any other difference of opinion? Anybody else?
That is management contracts, I think. Publicly owned utilities
Correct.
managed by private operators.
Correct. Correct. Yes. So that's a management contract. You're absolutely right. So yes. So it's not see these again I'm not saying that Gaurav was completely wrong. The whole idea is that all these are just minor differences. So these terms, that's why we are discussing these in detail so that we know what is that minor difference which is there. So by definition it is a management contract which is like a publicly owned utility which is managed by a private contractor. So water concessions again it's very similar. So can you find something which is very similar from the options and then find a better option for that?
B option.
B option, private operator operates the publicly owned system, collects revenues and shares with the public authority, which is responsible for investment.
No,
Again,
I
there's a okay, yeah, somebody else is saying something. Okay, it's not B, it's not the option two, it's not that. I think there's a better option there out there. Okay,
Correct option is A.
Then only it left, man. The correct option is A.
private operator is responsible for both operation and investment. Correct. Yeah. So again, we are talking about concessions right now. But what about the first one? Uh, we directly went on to B. We did not look for A. Divestitures, what is the
Diversity. The answer for diversity is 3, and the correct answer for A for 3 is only for A option. So we can directly say that correct answer is A.
okay, so you're saying that option A, the answer is 3, which is infrastructure assets are sold to private investors.
Yes, yes.
So, okay. Anybody else? Any other opinion? Mm,
A is correct, I think.
A is correct. Okay,
Option
so
A.
majority are saying A is correct. Uh, okay, so let's go into the definition, what we saw in the lecture. So this is what we saw. So private public partnership. So we saw that it's a delegation of responsibilities. Now, divestitures in that infrastructure assets are actually sold to private investors. It's not that they are given the responsibility, but it's sold to them. So option A, again, we'll come back to that later. Then in concessions, the private operator is responsible for both operation and investment. And in lease FMHs, the private operator operates a publicly owned system, collects revenue, and shares it with the public authority, which is responsible for the investment. So that's a lease FMH uh, contract. Now, in management contracts, this we discussed, is that publicly owned utility is managed by a private operator. Then we also have the mixed ownership companies where private investor, mainly a minority share, operates it, shares financial and shares the financial gain. Then we have a build, operate, and transfer project, technical assistance, and service contracts. So this is the definition that we know. So first one, A, the correct answer for A is infrastructure and assets are sold to the private operator, which is in 3. Yes, infrastructure, it is sold. Yes, correct. Then in concessions, uh, yes, we already discussed concessions, so it will go there. Private operator is responsible for both. Then in lease FMHs, we have private operator operates publicly, so it's this one, and management contracts is this one. So you're right, option A is the correct answer. I mean, I know just by looking at this, it was easy to solve the correct answer, but we had to discuss all the other options also. Right. So, shall we proceed further? Yes. So, in question 12, which of the following statements is false concerning water sensitive planning? So, it involves a provision of ecosystem services for the natural environment. It does not involve the provision of ecosystem services. It involves reduction of demand for potable water by using harvested rainwater, treated wastewater, and water efficient appliances. It involves adaptive multifunctional infrastructure and urban design reinforcing water sensitive behaviors. So, what is water sensitive planning?
It will be D.
It will be D is the, so false. We're talking about false. It involves adaptive multifunctional infrastructure and urban design reinforcing water sensitive urban behavior is false, is what you're saying.
No, no. Answer is B.
Answer is B.
B,
It
B.
does. Yeah. So answer is B. It does not involve the provision of eco. That's very simple. Like from by looking at the options, we can say because the whole idea of water sensitive planning is that it should have. We're looking into the ecosystem. So if we say that it does not involve the provision of ecosystem services or built environment, it is wrong. So yeah, you're right. This is the answer which is wrong. So let's also look into how it involves ecosystem and what about the other options? Like, are they wrong also? So this is what we learned in our lecture. The entire lecture 5 was dedicated to water sensitive city. where we saw that there can be different forms of like how we reach a water sensitive city. So it can just be a water supply city where there's supply hydraulics are in place. Then you can have a seaward city where there's sewerage lines and that's taken care of. Then there's a drain city where drainage channels are laid. Then you have a waterway city where you have diffuse waterway, the social amenities, the transfer, pollution, all that are also taken into consideration. And then you have a water cycle city where it protects what protection of water is also there. And then you have water sensitive city where there is more advanced practices or inputs are also put in order to save water, reinforce more water, or harvest water, reinforce the groundwater levels. So all that. So that's what we're talking about in a water sensitive city. It's a gradual process. And when we come to this final water sensitive city, there are three aspects which we need to consider. The first one is that it has to have access to a diversity of water sources by diversity of central and decentralized infrastructure. So we are talking about some diversity. It should also have provision for ecosystem services. And finally, the social and political capital investment for sustainability and water sensitive behavior should also be there. So when all these three are put into place, only then it becomes a water sensitive city. So that's what we are discussing over here in water sensitive planning. We need to have provision for ecosystem services. Then the advantages of this. So yeah, so we said that this is the best which is there. We are where we are increasing the rainwater, groundwater level, harvesting the rainwater. So all the water conservation techniques are involved in the water sensitive city. So option C, it involves reduction of demand of potable water by using harvested rainwater, treated wastewater. This is also correct. I mean, correct in the sense, yeah, this is a correct option. This is a wrong option. That's why we're getting. So this is correct. Then involves adaptive multifunctional infrastructure and urban design for reinforcement. That is also correct. So all these three options are correct. So the wrong option is B. So for this one, the option B is the answer. Yes, so these were the key. This is again from the lecture. So these are the key principles which are there that reduce the demand for potable water. So this is what we just discussed. Now the next question is also along the same lines. So we'll do that together. So which is again false considering the planning. Oh, sorry, this is the same thing. Sorry, this question 13 is the same thing. Water sensitive design measures can be undertaken only at an individual and street scale level, only at a neighborhood and street scale level, only at a neighborhood and city scale level, at an individual, street, neighborhood, and city scale level, which is the correct answer.
D.
D. So this is,
D.
yeah, we just discussed. So it can be done at individual level, street level, neighborhood, and city scale level. That's what we have seen in our lecture also. Right. So let's proceed. The urban local bodies responsibility under the Jal Shakti Abhiyan include which of the following? So what is Jal Shakti Abhiyan?
Is it Abhijan or Abhiyan?
Okay, I might be pronouncing it wrongly. Maybe it's Abhiyan. Yeah, it's the same thing. Jal Shakti Abhiyan. Yeah, it's the same thing. I think but there should not be a type. I'm not sure. This was there in the question
I,
paper as such. So yeah,
I think it's written wrong. Like that must be the typing
yeah.
error.
It's it. Anyway, yeah. We discussed in the lecture. We discussed the same thing. So yeah, maybe I'm pronouncing it wrong. I'm not sure.
It is Abhiyan, but
Okay,
I think maybe the professor is Bengali, so he is pronouncing it Abhijan. I'm also
maybe.
Bengali, that's why I'm saying.
Okay, maybe. Yeah. So okay, so it's Abhiyan. Good. Thanks for correcting me. So this is what it is. So we are trying to save it's a water conservation method that has been launched by the government. So it is different water conservation methods. So let's look into the options which are there. So does it ensure all government so is option, yeah, so we have to mark the correct option. To ensure all government buildings, center, state, and urban local bodies, and all public buildings, educational, to have a working rainwater harvesting, RWA, rainwater harvesting structure. So is that option correct?
Yes.
Yes, correct.
Yes, so it's correct. That's the whole principle of Jal Shakti Abhiyan. And in option B, persuading group housing societies to develop rainwater harvesting structures.
Correct.
That's also correct, yes. And option C, building permissions to be granted on the incorporation of rainwater harvesting structures.
Correct.
Yes.
Yes, that's also correct. And last one, D. concretizing of pavements around trees and laying of perforated paver blocks.
Correct.
Correct, yeah. So all these aspects are there. So option D is the correct answer. So it just basically lists all the different measures that is taken under Jal Shakti Abhiyan. Right. So that's what is there over here. Now, yeah, so we have all the responsibilities. So this is what is being discussed in the lecture. So yeah, so let's move on to okay, we are running out of time. Yeah, so I think I'll stop with this question. This can be the last question. Which of the following can be helpful in estimation of carrying capacity? Now, let's discuss what is carrying capacity. We discussed about the design period. So while we're discussing about design period, we also discuss about carrying capacity, which is mainly the I have doubts related to water demand. Yes, we will come to that. It's okay. I can extend the time a bit more. Don't worry. Carrying capacity mainly talks about the number of people that a service is catering to. Design period is a duration for which the service would cater to the people. Now, carrying capacity is for how many people are we designing it for? That's the carrying capacity. So that's what is designed over here. That we discussed over here. It can be defined as a maximum number of people that can be supported by that area, which can be based. Okay, so there are several factors which we look into while designing carrying capacity. Basically, it's the maximum number of people for whom we are designing the facility. So we have so which are the factors? Infrastructure capacity, it influences the carrying capacity. How? Because if we can invest more on infrastructure, then we can definitely increase the carrying capacity. So yes, institutional capacity, yes, if we have more capacity, or if you're having more investment and more policies or more institutional support in order to design something, we can increase the carrying capacity. So yes, environmental capacity, if we have the adequate resources, that also can it is important while estimating the carrying capacity. Yes, and sustainable capacity level, that's also important while estimating the carrying capacity. So option D is the answer for this. All of these are important. So I'm not going on to the next question. So I think I'll stop here and I'll take a few questions. Yes, somebody said they have some questions in water demand. Yes, what's your doubt regarding water demand?
Actually, I have a question related to fire demand. In assignment 3, you had given 3 questions. I am unable to solve because I didn't find the exact formulas for it.
Right. Could you enlighten me of what was the question or assignment 3?
They had mentioned that fire demand and the discharge per day, and then the fire rating. 2 hours per like that. Assignment 3 in that module.
Yes, so in this time's assignment, right, which
Yes,
which
yes,
was solved, yeah.
yes.
Okay, 1 minute. Let me just take that.
Week 2.
Week two, you're talking about.
Yes, yes, yes.
Okay. So week two we will discuss in the next week, like
Okay,
next
sorry for
Monday
the
only.
interruption.
No, that's
Sorry for the interruption.
totally fine. But yeah, I understood your doubt. Yes, I know which question you are referring to. So you can just directly use. So there are three methods which you can use, right? Like you can go for Kirchhoff formula, your fire demand, right? That's what
Yes,
you're
yes,
talking about,
yes,
right? Yeah.
yes.
So you need to take the okay, we will discuss this. I think you can hold on to it because we will do a similar problem next week. Because
Okay.
next week, like how we solved mathematical models today, we will be solving a similar problem. And I understand why the confusion is there, because in the lecture also there is a slight variation which you will have to follow. Since you asked it out, I'll just say you need to take the liters per capita, like you need not take it per day, you need to take it per hour. Then you can solve it correctly. If I'm right, where your
Yes.
confusion is.
In the first question, the big confusion is there.
Huh.
They had asked about the number of population and the water capacity.
Huh. Yes.
To just to tweak the question underneath, they had given the discharge ratio. While calculating that amount of capacity of that particular day, we are getting
Huh.
the answer. But while calculating with the fire demand, the answer is varying.
When you're calculating the fire demand, you're not getting the
Answer is very easy. Because if you are calculating for the amount of water required for that particular day, we are getting.
correct,
But
correct,
underneath that, another question is there.
correct.
We had to, they had given the mentioned about the discharge.
Yes, yes, I understood. So yeah, so you work it out this way. Anyway, submission will be only next Wednesday, right? So you hold on to this. We will discuss this in detail. Yes, there is some additional information might have also been given in the question. So maybe all the information in the question might not be required. That much I can
Yeah.
tell you.
Another is that the consumption, daily consumption, weekly consumption, average consumption. In
Yes.
that also some confusion is there.
Okay.
150% I had to take or 180% we had to take.
Yeah, so two formulas are given. You will have to take if you're taking the peak demand, you will have to take 180 1.8 times. We
Yes.
will discuss this in detail.
But we had to multiply with the 2.7.
So yes, you have to yes, I understood your, so there are two problems in that. Like if you're taking it per day, that varies than if you're taking it per hour. So for fire, the peak always happens per hour because for an entire day, the fire demand is not there. The peak will be for per hour. So if you go by that, then your
Yeah.
answer will be correct.
Yeah. Just I have small doubt.
Mm.
For how many hours you can take that? Entire day won't be there. We can consider 3 hours or 4 hours.
The duration of fire is not given in the question, right?
Yeah. Some they mentioned 2 or 4.
2 or 4. Okay, so I need to look into that question then. One sec. I was just.
If you
Uh,
have time, you can go. Otherwise, you can clarify in the next week. It's
I
not an
will
issue.
clarify in the next one because two reasons I do not have that assignment with me right now, which you are referring to, because I will only get hold of that next week. So I will discuss anyway. I will sort this next week because we will do a similar calculation next week. So don't worry about that.
Okay. Thank you.
Right. So any other doubts? Okay, so if no other doubts, then I think we can wind up today's session. So, yes, so I will be, the recording of this will be available. The link will be shared with you by NPTEL. Also, these presentations will also be made available. So, if you have any doubts regarding this session, also you can ask in the next week. And next week, yeah, we'll discuss week two's assignment and week two's lecture. So, I would urge to see the lectures and come. Then it would be a bit more easier. It can be a very good discussion. Today it was, in fact, a very insightful discussion. So, thank you all for joining and have a wonderful evening, or it's already night. So, have a good night. So, bye bye.
Thank you.
Thanks a
Thank you so
lot.
much.